Alrighty, so now we're going to do some practice questions that have to deal with finding the vertex and axis of symmetry for a quadratic, or for its corresponding parabola, I guess, starting from the standard form of the equation. So let's try that now. We're going to review that formula that we had, and we're going to talk about finding the coordinates, all kinds of stuff, and we'll even mix together a few of the previously done things that we looked at. So, determine the coordinates of the vertex of the graph of that function. So we need the coordinates of the vertex. Well, we know the x-coordinate is at the, or on the axis of symmetry. So we use our magic formula to help us get there. So we've got negative of b, which is 12, over 2 times a, which is negative 3. So this will be negative 12 over negative 6, and that gives us an answer of 2. So that tells us the x-coordinate should be at 2. So I guess we can eliminate those two. And now we got to find out what the y-coordinate would have to be. Well, y is equal to negative 3 times x squared plus 12 times x minus 10. So we just fill in the value of x that we found, which was a 2. And that's going to give us negative 3 by 2 squared, which is 4. Plus 12 times 2, which is 24, minus 10. So that's a negative 12 plus 24 minus 10, which looks to me like positive 2. Okay, so this one's out. And the only correct answer there is D. Alrighty. This question, it looks like they're trying to trick you up with a couple of sign mistakes there. And the negative 10 is probably counting on a miscalculation. Yeah, right there. So, no big deal. Stick to your guns, order of operations, and all that stuff. You should be okay now. This one looks like it's got more to it. For the equation y equals negative x squared minus 2x plus 4, determine the equation of the axis of symmetry. Okay, let's do that first. So first things first, we want our axis of symmetry. The aus. Okay, so x equals negative b over 2 times a. And b here is a negative 2, so it's negative of negative 2. Divided by 2 times a, which in this case is a negative 1. So that's going to give me, let's see, positive 2 over negative 2, which is a negative 1. So there's the equation of the axis of symmetry. Done. Next, they want the coordinates of the vertex. Okay, we already have the x-coordinate at the vertex. So to get the y-coordinate, we take our equation, and we leave some blank spaces with some brackets. Is what I like the way I like to do that, where x used to be. And plus 4, so that's directly from the equation at the top, and then I fill in a negative 1, which is what we found the x-coordinate at the vertex to be. So this is the negative of negative 1 squared is positive 1, plus 2, plus 4, so that's going to be a positive 5. So it looks like our vertex, sometimes I just write v with brackets for a vertex, is going to be at negative 1 and positive 5. Okay, so that's the first two taken care of. Next we have the maximum or minimum value of the function. Well, first we need to know, will this function have a maximum or a minimum value? Okay, so let's see. Do we have a maximum or do we have a minimum value? Well, we look to a, which is the leading coefficient, and we see that it's negative, which means the graph opens downward. Oh, it's negative. And that means it's going to have a point at the very top. So in this case, we have a max. And the maximum value is the top, or the y-coordinate, of the vertex. And that's going to be y equals positive 5. All right, that's not so bad. And then we want to find the y-intercept. So that's a little bit of a blast from the past here. We haven't done that for a couple of sessions. So y-intercept is actually, if you remember from this form, the y-intercept corresponds directly to the value of c. So we've got a y-intercept with x equals 0. And y equals 4. So there's our y-intercept. Okay, so all the same stuff. Negative b over 2a gets your axis of symmetry, same as your x-coordinate at your vertex. And the y-coordinate we get by substituting that number back in the equation. Sign of the leading coefficient, a, determines whether the function opens up if it's positive or down if it's negative. If the graph opens upward, we have a minimum, and if it opens downward, we have a maximum. And that's most of what we need to know about axis of symmetry, vertex, all that good stuff from the standard form. Good luck, and we'll see you in the next session.